Hello students, today we will study instantaneous rate and how to find out instantaneous rate. This is our graph. Consider this graph. This is graph for reactants. We know that as reaction proceeds, concentration of reactant decreases and product increases. Okay, so at time t1, suppose this is the concentration of reactant. At time t2, this is the concentration of reactant. So average rate of reaction, you are knowing students, that is minus del R upon dt, because concentration of reactant decreases and concentration of product increases. So what is instantaneous rate of reaction? This rate of reaction is between two time t2 minus t1. Del R equals to R2 minus R1. Okay. Now del T means T2 minus T1. So this is for between two times T2 and T1, this concentration. But if you want to find out the rate of reaction at a particular moment, particular instant, then we have to find out the instantaneous rate. So this is RAV, that is minus upon del T, average rate of reaction. But we find out instantaneous rate of reaction for a particular movement. At this time, the change in time is 0. There is no change in time. Del T approaches 0. So we will change this del by small d. Okay. So we will write RINST, instantaneous, equals to minus small d R upon dt, like this. This will be our rate of reaction, to find out rate of reaction for a particular movement. So this will be our formula. dt means very small time, when there is no change in time, for a movement rate of reaction. So this we will understand with one example. Let us take one example of hydrolysis of butyl chloride. Now butyl chloride, this side I am taking concentration, change in concentration with time. Suppose we want to find out change in concentration or rate of reaction at a particular moment, say 600 seconds. Suppose this is 600 seconds, this time is in seconds. Okay. Now touching this point, you will draw one tangent like this. That should touch the curve at this point, tangent like this, and then join. It should make 90 degree. This will give our dr. Okay, dr, and this will give our dt. So how to find out? You see the properly graph here. Change in concentration is decreasing with time. This is our graph like this. So if we find out instantaneous rate of reaction for a particular movement, we will take these two times. 800, our T2 minus T1 will be 800 minus 400. Let us write here. So 800 seconds minus 400. Then what about R? R is your R2 minus R1. So which will be your R2 minus R1 this time? The T2 we will take here. Here concentration we will take your, that is R2, and this concentration will be another concentration, this one and this one. So write like this here, R2 minus R1 यहाँ पे का और यहाँ पे का हम लेंगे, that is R2 minus R1, and it will be in your minus, because concentration of reactant decreases with time taken. So this will be more, this will be more, and this will be less, but here we are minus less, so we will get minus will cancel. Okay, this will be more, this will be less, but we have taken this one first, so minus will be cancelled. In this way you can find out the instantaneous rate of reaction for a particular movement. Okay, we will take this and this time, this minus this, and this concentration minus this concentration. I am making here like this. like this. Okay, so what is instantaneous rate of reaction? Rate of reaction at a particular moment when del T approaches 0 is called instantaneous rate of reaction, and we write like this. And for product increases, we write dr upon dt. So this is student. Now if you want this type of explanation, please subscribe my channel. Thank you.